Okay, today we are talking about lesson 2.16. Last Friday you took a quiz to show what you've learned from 2.1 all the way to 2.15. You will get that back in your Panda folder this Thursday, and I'm going to give you a hint. Lots of you will want to do test corrections, okay? I noticed some patterns. Lots of us understand the concepts, but we're just not being careful when we're doing our math. We're either not doing the calculations correctly because we're getting our math facts confused, or we're not lining up our place value. We're not adding up numbers correctly, or sometimes, most often, we're not reading the problem carefully enough. So every day when we practice the problem of the day, that's giving you an opportunity to practice problem solving with word problems. Okay, so today we're going to first talk about the problem of the day, but before that, let's talk about our learning goal. Today's 2.16, and today we're going to be talking about using what we know about dividing by 10 to help us divide whole numbers. Let's think about this chapter. So far we've done expressions, right? We learned how to write expressions. We learned how to multiply whole numbers and decimals. Then we learned how to use what we know about multiplying to help us convert measurement. And now we're going to move into talking about division, okay? Let's first talk about the problem of the day, though. Here we have 420 divided by 10. Now I know we know how to do this in our heads, yes? But today we're going to practice how we can use discs to model it, okay? So I can model the number 420 using discs. How many hundreds do I have? If I put 100 in that disc, how many of those 100 discs do I need? 4, because I have 400. Okay, so go ahead and write this in your notebook too. Now if I have 400 discs, is that 420? No. I also need how many 10 discs? 2. Now, all together on the left-hand side here, have I modeled 420? Yes. Okay, let's divide each disc by 10. If I'm going to share 100 equally by 10, how many do I end up with? What's 100 divided by 10? 10. What about this 100 here? If I want to divide this one by 10, how many do I get? 10. What about this 100? 10. And finally, this last 100, I get? 10. Okay. Now, what if I'm going to divide this 10 by 10? If I have 10 and I want to share it into 10 groups, how many does each group get? 1. What about this one here? 10 divided by 10 is 1. So therefore, over here, originally I had 420. And when I divide it by 10, do I have any hundreds left? No. How many 10s do I have? 40. I have 4 10s for a total of 40. And how many 1s do I have? 2. So therefore, 420 divided by 10 is 42. You already knew how to do that in your head, yes? Did you know how to model it using discs? No. Should you write it down in your notebook so you have an example of what it looks like when you model with discs? Yes. Definitely. Back in Module 1, we could say that when you divide by 10, we just talked about it during the problem of the day, you would move the decimal point over by 1, right? To the left. But what if we didn't want to do that? What if we wanted to shift the digits? Do the digits need to shift to the right or to the left? The left. Let's see. If I shift this 4 to the left, it would become 4,000. And the 2 would become 200. Is that what we want? No. So do they shift to the left? No. The digits shift to the right. Why is that? Talk to your table group. As a review, when the decimal moves to the left, is that the same thing as the digits moving to the right? Is it the same thing? Yes. Okay. Reagan, we need to think before we talk. We can't just say things just to hear our own voice. Okay. So therefore, 420 divided by 10 is 42. Okay. Sometimes we might have this problem. 24,000 divided by 600. Well, could we split up 600 into 10 and 6? So is this the same thing? 24,000 divided by 600 is the same thing as 24,000 divided by 100 and then divided by 6, right? Okay. Does that make it a lot easier for us to do? Sure. Let's see. Let's do this first part first. If I have 24,000 divided by 100, how does that affect the decimal point? I need to move it 2 spots to the right. Okay, so let's see. If I move it 2 spots to the right, then the number is 24, 1, 2, 3, 4, 5. Is that what we want? No. So do the decimal points move to the right? No. What does shift to the right? You guys are right. We could think of something shifting to the right, but it's not the decimal point. Talk to your table group. So because we decided it's easier for us to think of the decimal point moving, if I want to divide 24,000 divided by 100, in the number 24,000, where is the decimal point? I don't see a single decimal point. Ella, where's the decimal point? Yeah. Okay, if our decimal point is all the way to the right, how many spaces to the left does it need to move? Tara?
It needs to move 2 times.
Well, how do you know it needs to move 2 spaces to the left?
Because 100, you can also say that that's to the power of 2.
Yeah.
And the 2 shows that you need to move it 2 times.
You got it. I love how you referred back to exponents from Module 1. We know that 100 is the same thing as 10 to the power of 2, so I need to move it 2 times to the left because I'm dividing. So my new number is what? 240 divided by 6. Now can we use what we know about math facts? 24 divided by 6 is 4. But how many powers of 10 do I still have? So I need to add 1 0. Therefore, 24,000 divided by 600 is equal to 40. Good.